Okay guys, Assalamualaikum and a very good day. So, today, before I start our lecture, I will go through a few points from a few points from previous lecture as a recap. Okay, so as you know, there are 3 points in these topics, which are equilibrium point, linearizations, and Lyapunov. Okay, now what is equilibrium point? The first equilibrium point, the first one. Okay, equilibrium point is the coordinate. Macam nak kena cari dulu kat mana tu lukis tu. Is the coordinate where your system kat sini. Where your system is stable. I think here. Where your system is stable. So equilibrium point, a recap, is a coordinate where the system is stable, rest, or not moving. Okay, so that's the second point. That's the first point, sorry. Okay, so coordinate on the phase plane graph. Macam mana nak lukis? How we draw the phase plane graph? Okay. X-axis, x1, y-axis, x1 dot or x2. Okay, x1 dot always equal to x2. Okay, alright. Okay, then the second one actually, the second one that I want to explain is Lyapunov. Okay, Lyapunov, we want to check the stability of the system for nonlinear system. Lyapunov, okay, stability for nonlinear. We use Lyapunov. Stability for linear system, we use position of the poles on the S-plane. Okay, so you have to know how to differentiate these two. Nonlinear, how to check the stability of the system. If the system is nonlinear, you use Lyapunov. If the system is linear system, you have to see the position of the poles on the S-plane. Okay. If you want to check the stability for the system, for linear systems, mana hari tu? Hilang dah. Ding. Sorry guys, I try to find one of the calculations. Okay, if you want to find or to check the stability of the system for linear system, you can simply factorize the characteristic equation. Then you get the location of the poles. So you can check either the system is stable or not stable, unstable system. Okay. But if the system is non-linear, you cannot simply factorize complex characteristic equation. You cannot simply factorize the equation. So that you have to use Lyapunov Theorem in order to check the stability of the non-linear system. And in Lyapunov theorems, there are some conditions you have to follow. Okay. So if v dot or derivative of v greater than 0, so the system is stable, unstable, or energy is increasing. If v dot is equal to 0, so the system is naturally stable or energy stay the same. And if v dot is less than 0, so the system is asymptotically stable or energy is decreasing. So what's the definitions of v dot? V dot or derivative of v d over dt is a future value. Okay, let's say we have v is current value, and if we integrate the integration of v, okay, so here is the past value. Okay, so d over dt, v current value, and integration of v is a past value. Okay, now examples of Lyapunov. So this is the past year questions. Okay, I extract this from the, can't remember which semester, but this is the past year questions. So if the Lyapunov function of the system is given as following, determine either the system is stable or unstable. So this the nonlinear systems. Okay, the order is higher or greater than 1. Okay, so these are nonlinear systems. You cannot factorize it. Okay, if you expand the equations, you cannot factorize it. So obviously we have to use Lyapunov in order to determine either the system is stable or unstable. Okay, now your v have two functions, function of x1 and function of x2, equal to x1 squared plus 4x2 squared minus x1 power of 4 over 2. So first you have to derive, since it has two functions, x1 and x2. So dv over dx1 plus dv over dx2. Okay, now we do it one by one. Wait. So number 1, another one we use purples. This is number 2. Okay, let's say dv over dx1 is equal to, okay, now based on these equations, so first 2x1 plus, now here there are no x1's equations in this value, so 0 minus 4x1 power of 3 over 2. Okay, then the second one, dv over dx2 equal to, now there are no x2 equations, so 0 plus, okay, the second value will be 8x2 Then the ones no x2 function here, so plus 0. Okay, so now you get the derivations of both equations. So 1 plus 2 is equal to 2x1 minus 4x1 power of 3 over 2 plus 8x2. Okay, so we simplify the equation. Okay, equal to 2x1 1 minus x1 squared plus 8x2. Okay, now the few conditions of x1 and x2 you have to consider. Let's say x1 is equal to 1, where x1 is greater than 0. So 2, 1, 1 minus 1 plus 8x2. Okay, so sini kita dapat apa? 0 plus 8x2. So from here, if x2 greater than 0, okay, so V0 will be greater than 0, so the system will be unstable. Okay, what if, condition number 1, what if x1 less than 0? So let's say x1 is equal to negative 2. Okay, so 2 times negative 2, 1 minus 1 minus 2, negative 2 squared, so 4 plus 8x2. So ini kita dapat negative 4, negative 3. Okay, so positive 12 plus 8x2. So if x2 greater than 0, V dot is greater than 0, so the system will be unstable. Okay, if let's say V dot equal to 0, so 12 plus 8x squared is equal to 0. Therefore, x2 is equal to negative 12 over 8. So, if x2 is equal to negative 12 over 8, so therefore the system, if V not equal to 0, so the system is naturally stable.